Today, I'll be eating aluminum. Yes, that aluminum. But also, not really. In this three-part series, I'll be using different solutions and chemical compounds to break down that same aluminum foil from your kitchen and make it unusable, for fun. In this episode, I'll be using a strong base, sodium hydroxide, also known as lye. Sodium hydroxide is a very corrosive substance and direct skin contact should be avoided. However, in a solution of water, it completely ionizes and dissociates into its sodium and hydroxide group. This leads to an increase in the pH of the solution, making it more basic. The reaction I'll be doing today is the same one for why sodium hydroxide should never be stored in aluminum containers. A typical piece of aluminum has an oxide layer, formed through aluminum's exposure to oxygen. When sodium hydroxide meets this layer, it begins dissolving it to create sodium aluminate and water. After that, the sodium hydroxide is faced with pure aluminum, which then leads to sodium aluminate and hydrogen gas being made. To begin, I started by doing math. Since hydrogen is a very explosive substance, I didn't want to make very much of it. However, I did think it would be cool to collect as it has many of the same properties as helium, as they are both incredibly atomically light gases. 1 gram of hydrogen gas is equal to around 0.16 moles of it, which when plugged into this equation, leaves us with around 13.2 grams of NaOH and 8.9 grams of aluminum. Afterwards, I measured my chemicals. Then, I made my sodium hydroxide solution, the solution that will be eating up the aluminum. Since adding a strong base or acid to water is an exothermic reaction, I began by preparing an ice bath for the beaker. Then, I added 250 milliliters of water and dumped all the sodium hydroxide into the beaker. Honestly, I probably shouldn't have done this as it definitely could have boiled or led to an explosion of steam. Luckily, the sodium hydroxide pebbles didn't dissolve quickly and I was able to slowly dissolve them all. I slowly crushed pellets to help speed up the process. Then I brought the setup outside and funneled the solution into an Erlenmeyer flask. After that, I put in all of the aluminum and covered the flask. Immediately, you could already see little bubbling as the solution of sodium hydroxide began reacting with the aluminum. After a while, the balloon also visibly increased in size as hydrogen began filling it. Zooming in, you can see the solution start to turn gray as sodium aluminate is being created. After around 5 minutes, the balloon was able to stand upright, and at 9, my phone battery died. So I lost the active recording footage, so I decided, well, I'll just rerun the experiment. So while that's unfortunate, I kept the half-dissolved aluminum and re-ran it. I remeasured the ingredients and redid all the steps above. This time, however, I slowly added the aluminum one piece at a time. Theoretically, this should get pure hydrogen as less heat is produced and water boils less quickly and creates less steam. Unfortunately, I didn't have the patience to wait, and it was starting to become nighttime. Oops, I popped the balloon. Testing it, the balloon didn't float either, meaning there was still too much water vapor in the balloon, or I just didn't collect enough hydrogen, both of which would cause the balloon to be more dense than the air. After around 30 minutes, most of my aluminum foil had dissolved, with only small, very small pieces left. This experiment was quite successful. I managed to more or less completely dissolve the aluminum foil in a relatively short amount of time. To end things off, I wanted to quickly mention an observation I made with the half-disintegrated aluminum foil from the first experiment. Even an hour later, I could still hear the aluminum foil hissing as trace amounts of sodium hydroxide reacted with the aluminum. Anyways, thank you and goodbye.